7th grade math, test 21, study guide. Problem number 1, they give you a diagram that has 4/5 cups of sugar and 3 cups of water, and the question is, what are the number of cups of water for every 1 cup of sugar? So, since they said sugar last, we'll put sugar on the bottom, and the amount of water they had is 3 cups. The amount of sugar was 4/5 cups, and remember, all fractions are division problems, right? So that's why on top we divide by bottom. So 3 divided by 4/5 is the same as 3/1 times 5/4. Remember, multiply by reciprocal. Factor trees, cross out your 1s and multiply. Now, since this is a word problem, we'll go ahead and convert this to a mixed number. So there's 3 3/4 cups of per each cup of sugar. Number 2, which expressions below are equivalent to 8x minus 32? So what we're going to do is simplify all the expressions. We're going to do our rule for subtraction first and then distribute. 8 times x is 8x. 8 times negative 32 is negative 256. There's a work off to the side. That's not the same as the expression they gave me, so don't pick that one. Next one, number 2 says, expression 2 says 8 times x minus 4. So we do the rule for subtraction and distribute again, and I see that I get the same exact thing. 8x minus 32 is the same as 8x plus negative 32. Expression 3, we go ahead and do the rule for subtraction, and I draw 2 sticks here and I distribute. 2 times 4x is 8x, and 2 times negative 16 is negative 32. Over here, expression 4, again, we're going to distribute again. First do rule for subtraction. 2 times 4x is 8x, plus 2 times negative 32 is negative 64. Those aren't the same, so the only 2 that were the same were expressions 2 and 3. Alright, so number 3, it says find p. This one's very confusing. If you just try to simplify both of these first, it'd be very hard to figure out what p was. But if you notice, it's addition, and addition is commutative, meaning you can flip these around. If you flip these around, now it's a very simple problem. You see that these 2 are the same, and these 2 are the same. So in order for these 2, what does b have to be? Clearly, it has to be 5. So the trick there is to go ahead and flip those 2 around. So number 4 says, which description below matches a solution for the inequality? This is inequality right here. So what we have to do is we have to solve this first. We do the rule for subtraction. Then we isolate the variable by working farthest away from the variable, doing an inverse operation. The opposite of negative 2 is to add 2, but I got to do it to both sides. So that's where I get 16 on this side. That gets rid of these 2. Cross these 2 out. And all we have left over here now on this side is, oops, sorry, I wrote a 14 there. It's supposed to be a 4. And so what I do next is to isolate the variable, I divide both sides by the coefficient. And 16 divided by 4 is 4. Now, my answer is everything less than 4 if 4 is greater than my answer. So if I say the variable first, that's less than. So that's why it's an open dot, arrow to the left. Number 5, Julia wants to buy a $200 judo gi. She already has $71 saved up. Her dad gives her $2 for every stall that she cleans. What's the minimum number of stalls in order to get the gi? Well, this is a situation where she has money, she wants a certain amount of money, and she's earning money. So the money that she earns has to be the same as what she needs or more than what she needs. It can't be the other way around. She can't earn less than what she needs. So that's why the mouth is towards the variable this time. So we work farthest away from the variable, subtract 71 from both sides, divide both sides by 2. And we see that in dividing both sides by 2, here's the work real quick. I know it's sloppy, sorry about that. Our answer is everything equal to or more than 64.5, but you can't clean 0.5 stalls. Dad's not going to like that, so you're going to have to round up. It's one of those situations where you always round up. Even if it mathematically round down, you would still be short. So you'd have to round up every time this time. Problem number 6. Says Lucas has $18 to buy candy. He has picked out 8 lollipops that cost 20 cents, and he wants to buy some sour candies for 45 cents each. What's the max sour candies he can buy? Well, this is a situation where he already has money. He's not earning money, and he wants to spend money. So the money that he spends can't be more than what he has. So that's why this time the variable's away. The amount is away from the variable. So we got to multiply the 0.2 times 8, which is 1.6. And if you had 1.60, it's the same thing. Work farthest away from the variable again. Subtracting, since it's positive 1.6, we do the opposite. That will get rid of it on this side. Remember, our goal is to get the x by itself. If I have 8 and I subtract, here's the work over here for that part. Remember to line up your decimals there. And then we divide both sides by 0.45. The work's right there. And you're going to get 36.4 repeating. Now, our answer needs to be less than this. Now, even if this was 36.9, we wouldn't round up. Because in this situation, remember, he has some money, he's spending money. Even though it rounded up, it would be too much money. So we'd always have to round down. Even the inequality tells us what to do there to round down. So that's why it has to be 36 sour candies. That's the most he can buy. All right, so number 7. Number 7, we have Jack is draining 20,000 gallon pool. He already drained 8,000 gallons. The water drains at a rate of 22 gallons per minute. Write an inequality to match this. Well, M stands for minutes. And I want you to understand that the amount that he drains can equal the total, or we think about it as more. Okay, so it can be greater than or equal to the amount that he drains. I know it's not really possible, but it couldn't be the other way, right? If we want to know how much until it's totally drained, we couldn't just keep draining if it was less than that. I mean, the amount drained couldn't be less than how much we have to drain. I'm not sure if that helped you out or confused you, but anyways, the amount has to be towards the variable this time. And the total amount of water that needs to be drained is 20,000 gallons, so that goes on the total side. And the amount that's being drained is 8,000 is already drained, plus 22 gallons per minute, and that's our answer. Number 8, Ryan drinks 12 ounce. Ryan has a 12-ounce drink. He already drank 9 ounces. What percentage of the drink is left? So the trick here is the word left. Some of you would probably get this wrong because you're going to try to find 9 is what percent of 12, but how much is left means you have to subtract. So I subtract those two and I see that there's 3 ounces left. So the real question we're answering here is 3 is what percent of 12. So we use a percent proportion. Is over of 3 is what percent of 12. That's why 3 goes on top this time. It doesn't just go on top because it's smaller. Sometimes a bigger number goes on top. It's because it is over of. So then we cross multiply. 3 times 100, 12 times x is 12x. And divide by coefficient, 300 divided by 12, there's our work, 25%. So make sure, be careful. If they say left, make sure you subtract first. Alright, so number 9. It says we have a proportional graph, and on the y-axis you have number of packages, and the x-axis is time in minutes. Then they give us a set of coordinates 4 to 20, and they ask, what does it mean? Well, if x is minutes and y is number of packages, then that has to mean 220 packages every 4 minutes or per 4 minutes. But you have to be careful, because if you look at the other answer, if you get the unit rate, if you divide 220 by 4, that's 55 packages per minute. So there's actually 2 answers that work. So for this problem, please be careful. Check all of them. Don't just assume. Number 10. A woman bought an item and paid 8% sales tax. The tax added $20. Now, I emphasize that the tax added because that means $20 is the tax. Sometimes for these test questions, they say the original price was instead of the tax. So in that case, the 20 would go on the bottom. But because this $20 is the tax, remember it's is over of, that's why 20 goes on top. So like always, we cross multiply. 200 times 100, just put 2 zeros after the 20. 8 times x, put the 8 in front of the x. Divide both sides by the coefficient. And 2,000 divided by 8 is 250, so $250 is the original price. Number 11 says a dance instructor earns $90 for teaching 3 classes. Please be careful, because the first time I did this, I did it real fast, and then I had to change my notes because I didn't read that 3 classes part. I hope you don't make that mistake that I made, which means you have to find the hourly rate first. In other words, this instructor is getting $30 per hour. So after you find that, then you'll find 10% of $30. You use percent proportion, cross multiply and divide. And then once you get 10% of 30, which is 3, and I know some of you know 10% is as easy as moving the decimal one time, that's fine. But this way always works. Like if I said 9%, this would work as well. But at the end, you have to add that on to the 30, and with the raise, this instructor will be making $33 per hour. So 12 says, write 12 over 20 as a decimal, so we divide in and out. Make sure you put your decimal at the top. There's the work for that. 13. We have to write the value for this expression here. Well, we're going to do the rule for subtraction and make everything a fraction. Let's add these two first. When you're adding fractions, you need a common denominator, right? So you look at the bottom numbers, the denominators, and look at the multiples of those. 6 times 1, 6 times 2, 6 times 3, etc. The first time they're the same is what we call lowest common denominator. In other words, we're going to rewrite these same exact fractions, but so that they have these bottom numbers. And how do we do that? We're going to multiply the top and the bottom of this by a number. What number is it? We'll count. Look, 1, 2, 3. It's going to be 3 over 3. For 9, count. 1, 2. So it's going to be 2 over 2. So we're going to rewrite those fractions. So remember, what we're doing right now is we're adding 5/6 to negative 1/9. So 5/6, we multiply it times 3 over 3. If we do it to the top and the bottom, it's the same number. It just looks different. And same thing with 1/9. 1/9, another way to say 1/9 is negative 2/18. Now, when I add those two together, I taught you guys when you got a negative, always put it up top. So you put that negative up top. Now that they're the same size pieces or common denominator, I can use teams. Opposite teams mean subtract. Who has more? Positives have more. Therefore, 1/9 plus 5/6, negative 1/9 plus 5/6 is positive 13/18. So now I can add that to 3. Okay. If I'm going to add that to 3, then what I can do is I can just put it over 1. I make it a fraction. Get common denominator. So 3 over 1 is the same as 58 over 18, right? 54 over 18. 54 divided by 18 is still 3. So now that they have the same size pieces, add the top, and then you can convert it to a mixed number if you need to. Now, this works every time. For example, if 13/18 was negative, this would still work. But I want to show you a shortcut. When they are the same sign, if I have 3 plus 13/18 and I'm adding a whole number to a fraction and they're the same sign, I literally just put them together like this. That's the shortcut. That only works when they're the same sign. If they're both negative, both positive, this way works every time, even when they're opposite signs. That's why I showed you the long way first. Number 14, we have two expressions. There's nothing to distribute because there's no numbers right outside parentheses, so I just combine like terms. I add my x's together. I have negative 12 and 9 more negatives. Those are on the same team, so I add. Negatives have more because they're all negatives, and 6 plus 6 is 12. Number 15. So for 15, they tell us which expressions below show the distance between A and B. So they give us this number line, right, where A is at negative 5 and B is at negative 1, and the distance between those two is to subtract. Distance means difference, right? So when I subtract, I have negative 5 minus, let me show you this, negative 5 minus negative 1. Then I do the rule for subtraction. I draw my two sticks. Remember, never change that front one. And then I do teams. Opposite teams means subtract. Negatives have more. But distance is difference, and distance is always positive, so I take absolute value. So the distance between these two is 4. Since it's on a number line, the distance is 4. Now, when I do these expressions, I don't make them all positive like I just did. These are not distances. These are just expressions. So the trick here is this will always be positive, but these won't. These you're going to do rule for subtraction and teams and see when you get a positive 4. So if I look at example 1, 5 take away 4 is 4. Holy Moses. 5 take away 1 is 4. Expression 2, negative 1 minus negative 5. I do the rule for subtraction. I get a difference of 4. Expression 3, negative 5 plus negative 6. Negative 5 plus negative 1 is negative 6. And expression 4, the absolute value of 5 minus the absolute value of negative 1. Well, you got to do the absolute value first. Absolute value of negative 5 is 5. Absolute value of negative 1 is 1. 5 take away 1 is 4. And that's why we say G, excuse my dear Aunt Sally, right? Because it's all grouping symbols. It's not just parentheses. So do the work inside first and then subtract, and you'll see expressions 1, 2, and 4 are the same. Problem 16, they give us two similar shapes, and they tell us that they're scale image, which means they're proportional to each other. So if I put little over big, that's going to equal little over big from the scale factor they give me. So I got 9 over x equals 1 over 1 and 2/3. 1 over 1 and 2/3 over here. Cross multiply. Remember, when you multiply on anything that has to do with fractions, make everything a fraction, right? So we convert that to a fraction. 3 times 1 is 3, plus 2 is 5. 5 over 3. We do our factor trees, cross out our 1's, and our answer has to be 15. Number 17, they give us those two maps. And so for 17, if see, it tells us if we can figure out how many centimeters it is, we multiply that by 50, because every centimeter is 50. But that's for map A. So I got to get that distance. It says for Gladville to Columbus. So that's my goal. Problem is they don't draw it on map A. Okay, so what I need to do is I need to use map B to figure out how far it is on map A, so I can multiply it by 50 and get the actual distance. So again, we're going to check out the scale factor between map A and map B. And what they do in the problem is they tell us from Riverside to Gladville, they tell us in map A it's 12 centimeters, and map B it's 4 centimeters. Now that's not our goal. Our goal is Gladville to Columbus. But we can use what they gave us to figure out that map A is 3 times bigger than map B. Now that I know that map A is 3 times bigger than map B, then I can go to map B and get the distance from Gladville to Columbus. That's our question, right? Because if it's 1.2 centimeters on the smaller map, and the bigger map is 3 times bigger, all I got to do is multiply it by 3. Now I know that Gladville, and forgot my D there, Gladville to Columbus is 3.6 centimeters, even though they don't show it, because I use proportionality to figure that out. So I figured out map A is 3 times bigger, multiply it by 1.2, and now I know that it's 3.6 centimeters from Gladville to Columbus on map A, which is great because I know on map A every centimeter is 50 miles in real life, so I multiply by 50 and I get my answer, 150 miles. Problem 18, it says a circle has a circumference, and this is the first problem on this study guide where you guys should use calculators. Do not use calculators on any of the other problems. You need to keep those skills sharp because you can't use them on the test until you get to 18. So you can use calculators for this one, but not for the previous problems. 18, they give us the circumference of a circle. They tell us it's 19.9. Well, circumference is 2 pi r. I put the circumference where the C goes. 2 is always 2. Pi is always 3.14. 2 times pi is 6.28. So if I need to know radius, I can divide both sides by the coefficient. This is where you break out your calculator. 19.9 first, then division, then 6.28. And you know the radius is about that, but we can just go ahead and round it to the nearest whole number because that's what the directions say to do. 19 says once circle has a diameter, it's supposed to say one circle. One circle has a diameter of 10 feet. Another circle has a diameter of 12 feet. How much greater in square feet is the area of the larger circle? Now they're saying how much, not how many times. If they say how many times, that's division. If they say how much, you just subtract. So in other words, we just got to find the area for these two, right? They give us 2 diameters. If they give us 2 diameters, we just got to find radius by dividing it by 2. Radius for a 10-foot diameter is 5 feet. Radius for a 12-foot diameter is 6, so we put them in our formula. Area equals pi r squared. So I get out my calculator. Make sure you do the squared part. Go 5 times 5. That's not 5 times 2, right? 5 times 5, then times 3.14. You should get this. Next one, you should do 6 times 6 times 3.14. You should get this. Now leave this in your calculator and just hit minus this. And round it to the nearest hundreds. That's how much bigger. 19, they give us a shaded region. And we can see from that problem that it's divided into fifths, and 3/5 is shaded. So our goal is to find the area for the whole circle and then take 3/5 of that. How do we do that? Well, first of all, we got to get the radius for the circle. And then after we get the radius, we get the area of the whole circle, and then we just multiply it by 3/5 because 3/5 is shaded and 3/5 of means 3/5 times. So what we do to get the radius is we know that circumference equals 2 pi r. And they give us circumference, so we put that where the C goes, and again, 2 goes here, 3.14 goes here, just like last problem. Multiply those 2, divide by coefficient. This goes in your calculator. Put the top part in first. That line means division. Put equals, and we get a radius of 8. So area is pi r squared. Notice I didn't use approximate symbols up here because This is actually approximated already, so there's no need to put approximated because they're already approximated. So area is exactly pi r squared, but now I'm rounding 3.14, so I use the approximate symbol there. Make sure you do 8 times 8 first in your calculator, then times 3.14. You should get this area for the whole circle, and 3/5 of that means to multiply by 3 and then divide by 5. So type this in first, hit multiply by 3 equals, then divide by 5. Now, for those of you that don't like that, you can go 3 divided by 5 equals, get that decimal, which I think is 0.6, and then multiply it by 200.96. Alright, I hope that helped you guys out.